Hello, I greetings to my viewers. I'm your online assignment tutor. A student in SS1 came to me and he sent me mail that I should actually make a video to explain work, energy, and power in physics. And I know that it's very fundamental to know the definitions and some basic understanding that has to do with work, energy, and power. Something about physics is that once you don't know the theory, it will be difficult for you to do excellently well in your practical. So we have a situation in our hands now. So the first thing we are going to look at is what we are doing now is actually physics, and physics we are looking at work, energy, and power. Maybe you are preparing for WAEC and you are being asked to define work, energy, and power. You should know that it will be very good for we to know how to define these things. It's very, very important. So we will first of all look at work, we'll look at energy, then we'll look at power. So what is work? What is work? Now look at the definition of work. Work is basically force times displacement. Force times displacement. Work is basically force times displacement. In other words, you can say work is a product of force and distance in the direction of the force. So if we have an object in the horizontal surface and we want to push the object, maybe we are applying a force at an angle of theta. Let's say a force F. Let's say a force. We are applying a what? A force F at an angle of theta through this distance. Are you listening? Now, this force that is applied on this object at this angle theta, the work is equals to F times cos theta times D. F times cos theta times what? Times D. In essence, work will now be equals to F dot D cos theta. So that is work. F dot D cos theta. So now, what is the SI unit of work? The SI unit of work is actually joules, or we call it Newton meter. Or you call it what? Newton meter. That is very good. That is very good. So, in real definition, when we want to write it on Google, we can say work is the product of force, product of what? Of force and distance moved in force direction. Distance moved in what? Force direction. Distance moved in force direction. So the product of force and distance move in force direction, or in the direction of the force. So what we are having in the hand is that after you must have defined this, then you can come up with what? With the unit. You say it is what? It is measured. It is measured in joules. Measured in joules. And it is a scalar quantity. Is what? A scalar quantity. What do you mean by scalar quantity? I want you to follow me in this video, because that's why it's good to subscribe to my YouTube channel, because in the videos I will do, I'm going to explain scalar and vector quantity. How you can know whether a quantity is scalar and how you can know a quantity is vector. But work is what? A scalar quantity. So this is very important that you know. What do we say? We say work is the product of force and distance moved in the direction of the force. It is a scalar quantity and it is measured in joules. It is measured in joules. Let's take for example, let's look at an horizontal plane. Let's look at this object. A boy apply a force of 50 Newton at an angle of 60 degrees to the horizontal. So he pushed this object at a 6 meter to this point. So the distance from where he pushed the object to this particular point is 6 meter. So what now asks you, what is the work? So we are looking for the work done. So what is the work done? So the work done is actually going to be W equals 50 times 6 times cos 60. So if let me punch my calculator. 50 times 6 give us 300. 300 times cos, what's cos 60? Cos 60 is 0.5. So 300 times 0.5. That is what? That is 150. So my answer is 150 joules. So that's our answer. The answer is what? 150 joules. So the work done on this bulb is what? Is 150 joules. So let's look at another question. A boy. Let's look at another situation. So let's look at a boy pushes a crane with 30 Newton force at 10 meter at 10 meter, find the work done. So the work done in this case, the work will be what? 30 times 10. That is what? 300 joules. 300 joules. That is the work done on the crane. So another thing you have to know about work is that work, when you set to actually do work, when you actually apply the force such that the distance you apply the force on is in the direction, the distance in the direction of the force. If, for example, you push a ball along a straight road, in as much that the distance is in direction, the distance you push the ball is also in direction of the force, then you have done work. This is work. Now, in a situation where you have a ball and you push up with a force and you are having a perpendicular distance to the force, in this situation there's no work being done, because work has to do with force moving in direction, for the product of force and distance moved in the direction of the force. In this type of situation is what we call moment of a force. This is what we call moment of a force. This is moment of a force. So that is not work. In this course of this channel, I'm going to drop a video on moment of a force. So we have a full package in this channel. So another thing we have to know now is to look at energy. Energy. What is energy? What is energy? Energy is what? Ability to do work. Ability, or you can say is what? Capacity. The capacity or the ability to do work. The capacity or the ability to do work. It is a scalar quantity also. It's also a scalar quantity. And it is measured in joules. It is also measured in joules. So energy and work are the same quantity. They are measured in the same quantity. Energy and work are measured in the same quantity. If you don't have the energy, you cannot work. So that's why they say is the capacity to actually do work. So we have fundamentally we have the various types of energy, but in this video we are just going to look briefly at these two types of energy. We have the potential energy, and again we have the what? Kinetic energy. Kinetic energy. Let me write the kinetic energy well so that we can know the spelling. The Kinetic. So that is kinetic energy. Type of energy we have potential energy, we have what? Kinetic energy. Now, what is potential energy? Potential energy is the energy that has to do with position. How we do what? Potential energy, PE. This is potential energy. Is the energy acquired by the body that has to do with what? Position. That is why it is actually equals to mass times G. This is actually due to gravity times the height of the of the moving object, or the height of the height through which the object ascend or descend. That is potential energy. So it is also measured in joules. M is the mass. Is the mass of that object. G is the what? Acceleration due to gravity, which is always 10 meter per second square. Some textbook you see 9.8, depending on what they has you in the exam to take it as. So the H is the height of the moving object, or the height of the object itself. That is potential energy. When a body falls from the top of a roof downwards, we say the body actually, undergo, or body has undergone potential energy. So, and so also must take note that a pipe with a liquid running a pipe of height h, which a liquid runs into. Maybe you have a pipe and water rises from bottom to top. If you know the mass of the water, of course the water rises in gravity, which is actually what? G. Therefore we can find the potential energy. So the potential energy will be equals to M, the mass of water, times G, times what? Times H. That is very important for we to note. That's very important for we to note. So it's very, very important. Now that is all about potential energy. Let's talk about kinetic energy. Now, kinetic energy, let's say KE, is fundamentally equals to half M times what? Times V square. This is a very important formula in physics. Half times mass times V square. So the kinetic energy is the energy that has to do with motion. So energy that has to do with what? The motion of the object. So M is the mass, where V, which is mass, is in kilogram, where V is the what? Is the velocity. Velocity is what? Meter per seconds. So M is the mass, and the what? V is equal to what? The velocity. That is very important for we to know. So now, total mechanical energy in a body, let's say ME, total mechanical energy in a body is equals to the potential energy plus kinetic what? Energy. The total mechanical energy in a system, whether in the body or in a system, equal to potential energy plus kinetic energy. And now one thing we have to know is that when a body acquire kinetic energy by virtue of its motion, there is always amount of work also that the body too has actually done. Amount of work has been done, because the kinetic energy, potential energy, they are also measured in what? In joules. So if we have, let's say we have a situation where the potential energy equals to the kinetic energy. That is, the potential energy equals to the what? The kinetic energy. Let's say we have that situation. So if velocity attained by that object can be fine, velocity can be fine attained by that object during the time when potential energy is what? Equals to kinetic energy. If that is the case, then we have mgh equals to what? Half mv square. You see it now? So therefore, this will cancel. So we have what? V square equals to what? 2GH. So therefore, V will be equals to square root of 2GH. So this is velocity of the body when the potential energy equals to the what? Kinetic energy. This is the velocity. When we get to the escape velocity, when we are talking about gravitational constant, law of gravitational constant, and things like that, when we get to that place, this velocity is what we call the escape velocity. But that is not what we are doing today. So let's talk about the third one. That is power. That is power. What is power? Power has to do with the rate at which work can be done, rate at which energy can be expended. Your power will be determined by the amount of work you can do in a time. So we have force times distance over time. Force times distance over time. We have force times distance over time. So power is equals to work over what? Over time. Power is equal to what? Force times distance over time. So it is also a scalar quantity. It's also what? A scalar quantity. And it is measured in what? Joules per seconds. And the thing about joules per second is that we have a unit called watt. So watt is equals to joules per seconds. So it is measured in what? In joules. Power is measured in what? In joules per seconds. Measured in joules per seconds. And that is equals to what? Watt. That's equals to watt. It was discovered that also we have other unit called horsepower. So if you are giving horsepower, just know this conversion that 1 horsepower is equals to 750 watt. That is 1 horsepower. 1 horsepower is equal to what? 750 watt. 1 kilowatt equals to 1000 watts. That is 1 kilowatt equal to what? 1000 watts. So these are actually fundamental mechanics about work, energy, and what? And power. When we come next, we are going to, please, I want you to subscribe to my YouTube channel so that when we come next, when I drop a video on calculations on all the topics we will be doing now, you will be the first person to actually see it. So let us be very, very helpful to others by sharing these videos to others, by letting them know that they can gain, that the knowledge is not something that should be heard. You need to share it to others, and that's the essence of this video, for we to share it to others, for we to know that one can actually learn anywhere, any part of the world. You can give to your friends in UK, in US, anywhere. So this is very important. So what are the lessons we have learned today? Number one, we learned that work is what? Work is force times displacement, or distance moved in direction of the force. 2, we learned that energy is the what? Capacity to do work. So it's also force times distance. Energy is also force times capacity to do work. 3, we also learned that power is also force times distance, but now it's over what? Over time. So this is measuring in watts. This is measured in joules. This is measured in joules. All of them, they are scalar quantity. Note that they are what? Scalar quantity. And of course, you should know that every for work to be done, the distance must be in the direction of the force. That's why we say force times what? Displacement. The distance must be in the direction of the force. And of course, energy also is the capacity to do the work. If there's no energy, there cannot be work. Then we have power. Power is the what? Is the rate at which energy is being expensed, or at the rate at which work is being done. So we have come to the end of today's lesson, and I hope that you do enjoy it. So kindly subscribe to my YouTube channel. Share this video to any young person in science, maybe SS1. Let him refresh, let him gain from it, let him note it down, so that he can, prepare. I don't know the exam anybody is preparing for, but this is fundamental. And I thank for you for listening to this point. I want to say this before we draw the curtain of today's lesson. I want to say this is that, please, everyone that is viewing this thing, try as much as possible to email me. If there's anything that you don't understand, mail me. I'll swiftly respond to your mail. If there's anything you don't understand in the topic, or you want me to actually do a particular topic on a particular subject, on a particular topic, maybe in a particular subject, you can mail me or drop a comment below the video, and I'll be glad to respond as soon as possible. So do have a wonderful day. Enjoy the rest of your day. Bye bye.